Hello and welcome to the J4 S2 2022 CCC solution. In this video, I will be going through the logic behind my answer, some basic pseudocode, and finally I'll be implementing it in Java. Before I begin, if there are any optimizations that you see, anything that I should improve, anything that I should simply change, please feel free to leave them down in the comments. As for a link to the actual code, it will be in my GitHub, so I'll put down a link in the description to my GitHub. Yeah, that should be it. If you found this video helpful, if you find this video helpful, please share with someone else that you think might also find it helpful. If not, once again, please feel free to let me know any things I should do better. All right, let's begin. Yeah. Okay. Good groups. Our class has been divided into groups of 3. This division into groups might violate 2 types of constraints. Some students must work together in the same group, and some students must work in separate groups. Your job is to determine how many of the constraints are violated. Okay. So the first line will contain an integer x, with x being equal or greater than 0. The next x lines will each consist of 2 different names separated by a single space. These 2 students must be in the same group. All right. The next line will contain an integer y, with y being equal or greater than 0. The next y lines will each consist of 2 different names separated by a single space. These 2 students must not be in the same group. So similar to x, just not in the same group. Okay, among these x plus y lines representing constraints, each possible pair of students appears at most once. Okay, so if A and B are friends, so let's call X, so the group that pairs are meant to be together, let's call them friends, and pairs that aren't meant to be together enemies, just for the sake of simplicity. That means that if A and B are friends, then A and B cannot be enemies. Simply. Okay. The next line will contain an integer g, with g being equal or greater than 1. The next 3 lines will each consist of 3 different names separated by a single space. These 3 students have been placed in the same group. All right. Each name will consist of between 1 and 10 uppercase letters, does not matter for us. No 2 students will have the same name, and each name appearing in the constraint will appear in exactly one of the G groups. All right, so if a name appears on one of the G lines, it cannot appear on any of the other G lines. It only comes up one time. And every name is unique. Yeah, okay, the following table, okay, we don't care about the following tables because we're here to get all the points, not some of the points, right? All right. So yeah, we want to output the amount of constraints that are broken. So let's just go through the first example. And you know what? Yeah, let's just only go through the first example, because we can go through the second example while we're trying to figure out a solution. But for the first example, it's pretty easy. There's one constraint, and the constraint is LED and G have to be together. So x equals 1, and its input is LED and G. Y equals 0, so there are no enemies, and we got 2 groups. Dwayne, Ben, and Jolly, Chi, Francois, Elodie. So the only constraint was that Chi and Elodie have to be in the same group. They are in the same group, hence no constraints are broken. Beautiful. All right, I'm gonna slow it down, because I want to draw this out. I want to try to figure out what this would look like if we were to make it into a list, if we were to truly draw it out. So here we go. Our first task is to somehow find a data type, a data structure, a data whatever, that is able to hold all these values, specifically these pairs, right? The first X and Y lines are just pairs, so we need to figure out a way to hold these. So let's for example, let's make an example where X equals 0, and we have actually x doesn't equal 0, because that would be useless. X equals 1, and let's say the pairs that are meant to be together are A and B, and then Y equals 1, right? The groups, the enemies, and now we go B and C. All right, to show this drawing wise, it would look something like A line B, and this line would show that A is connected to B some way, right? Yeah, connected to B. But then B and C are enemies, so I guess we make a different line to C, and we put a line through it or something to show that B and C are connected, but they're not connected, they're enemies. So, just looking at this alone, we see two things. We see two criteria that whatever data structure we choose to hold this data, to hold this values, must meet. And the first one is it has to hold a value that points to another value. So it has to have a value that points to another value. So A points to B, B points to A, B points to C, C points to B, right? The second criteria is that it has to be able to tell that if these connections are friends or not friends. So friends, question mark? So that's to say, like, it also has to figure out if A and B are friends, which they are, right? But B and C aren't friends. So how are we going to be able to tell? Now, off the top of my head and off my research, I haven't been able to figure out a single data type that is able to hold these lists and also be able to hold whether they're friends or not, right? Like whether it's true or false, whatever. So instead of trying to find a data type that meets these two criteria, let's instead make it so we only have one type of data type. This data type, we have two of these data types instead, where we have B is now not connected to C. But these are completely separate. A connected to B is a completely different data structure than B is not connected to C. That way, we can have a enemies group, should be an enemies group, and we can have a friends group, right? And this way, we don't really need to care about if we are able to figure out if they're friends or not, because there's just two groups, friends and enemies. All right, now there's only one constraint left. We need to have a data structure that has value that points to another value. And I'm not sure if you guys are familiar with hash tables or hash maps, but those are perfect for the job. If you don't know what they are simply a data structure that has a key that points to a value. Simple as that. So, an example of that would be a string pointing to another string, which another example of that would be A pointing to B. Boom. We have found a data structure, please go away, that solves our criteria for our data structure. And we are almost ready to use this data structure. There's just one small problem left. If you were to look at sample input 2, so going back to my laptop, sample input 2, we see a small problem. In the sample input 2, we have A and B are a pair, and they're friends, G and L are friends, J and K are friends. And we see that D and F aren't friends. And then we see D and G aren't friends. Hence, we see D come up 2 times. D is not friends with F and G. The problem with that is that in this data structure, a string points to another string. A string doesn't point to a list of strings. So let's just do that. Let's instead of going string points to string, we're going to go string A, for example, points to an array list of strings. Why are we using an array list of strings? Well, because this way we don't need to know from before how many there are in the list, right? We don't know if there's going to be 1. In these cases, if there's going to be 2, what if we have 100? We don't know. So we have the dot add and dot remove function that we can use later on. Hence, it's perfect. Now it's going to look a little bit more like A points to an array where B is one of the values. This is what it looks like now. And it's perfect. It does our job perfectly. So, to show that, oh yeah, by the way, I completely forgot to mention this, but A right, is connected to B. So A points to B. But B points to A, right? It's not one way. It's not, they're attached. They're together. So A points to B, but B points to A also. That's also something important to consider. So now let's go ahead and actually draw it out. So let's go ahead and draw it out for the second sample input. So here we see the second sample input, and we all really need to care about the X and Y lines. So we go, okay, I'm gonna write it down really quickly, and I'll be back in a second. I just want to write it down. All right, we're back. So here we have, we have written out all the values. So X equals to 3, and then we have the inputs for X. And then here we have Y equals 2, and then we have the inputs for Y. So enemies and friends. So just to clarify, going back to right before, we're going to keep all this stuff is going in a hash map, right? All this is going right in a hash map. The hash map is going to hold a string that points to an array list of strings, right? So let's try to figure out how that would work out in actual code when we're going through it. So this is what code is going to look like. First, we're going to look at line 1, right? This line. And we're going to go, all right, A. Does friends have the key A? No, it doesn't, right? Because friends is empty right now. So we're going to go, all right, well, then we're going to add A, and it's going to point to an array where B is the sole value. So we're going to go B. Now we're going to look at B. We're going to go, okay, B. Is B in the key? Does friends contain the key B? No, it does not. Then we're going to make a new, we're going to put a new key in value, and the value of B is going to be A. We're going to do the exact same thing for G, L, J, and K. So G, there's no key for G, so we're going to go L. There you go. It's pointing to L. And L is pointing to G. So I'm going to go through this part pretty fast because it's really repetitive and there are no interesting cases that come with it. However, there are cases when it comes to enemies. So finally, K points to J. Now, let's look at enemies. D points to F. Do we have a key for D? No, we don't. So we go D points to an array where F is the sole value right now. Then we go, okay, F points to D, so great. We'll go F points to D. And once again, F is not, the enemies doesn't contain the key of F, so we can just add it. So we're going to put F, and it's going to point to an array list that holds the sole value of D. And then we come to DG. DG goes, all right, so D, does enemies contain the key D? Oh, wait, yes, it does. All right, well, instead of adding a new put D in this value, we're just going to add to this key. We're just going to add to this list instead, or this array list. So we're just going to go, all right, F and G now. We're just going to add to the value. But we're going to go, okay, but G doesn't, enemies doesn't contain the key of G. So we're going to go, all right, G. So G now points to D. But that's how the computer would look at this after. So this is what the computer sees after the following input, right? I hope that makes sense. And now that we have officially figured out a way to hold all the data, now we are able to go ahead and try to figure out some logic that would let us solve the problem. Okay, so here's that. It's perfect, right? We can just build on this. Now we have the line, the first line, right? So we have it to, if we look at the code right here, we have, so here are the X and Y lines. Now we're just looking at the G line. Sorry about that. I don't know if the voice cut out. Now we're just looking at the G lines. We're going to go, okay, 4 equals G. And the G lines go A, C, G, and then there's more, right? There's more. There's 3 more lines, but we don't really care about those lines. because we just want to figure out what we're going to do for the first line, and then we can go through the next lines. So how are we going to figure this out? Well, let's just make this a little bit bigger. A, oh, that should be C. C and G. So the first thing we gotta do before we do anything else is we gotta initiate a counter, or initialize a counter. This counter is gonna start at 0 and it's gonna increment. It's gonna count all the times we've broken a constraint. That's the first step, right? But then we're gonna go, all right, how can we tell if a constraint is broken through this line? Because this is a group, right? Well, how can we break a constraint? A constraint can be broken. Constraint broken can mean two things. The first thing is where a value is not with its friends, and another way a constraint can be broken is, and the second and only last way, is a value is with its friends. That's all. There's only two ways that we can break a constraint. So now looking at this list, how can we figure out a way? How can we use this logic, right, the simple logic, to figure out if a constraint is broken? Well, all we really gotta do is let's first loop through the values, right? Loop through the list, loop through the team, and go, all right, A, for example. We're gonna find the friends of A, which, by the way, are just B, and we're gonna go, all right, is B in the rest of the values? No, right? So counter plus plus. Now we go, all right, does A have, is the key A in the enemy section? No, it is not, so we just skip it. C is not in the friends, C is not in the enemy, so we skip it. G is in the friends. All right, so we go, all right, G, and it has an array list, and that array list has one value, it's L, so we're gonna go, all right, is L in the inputs? No, all right, then counter plus plus. Is G in the enemies? Does enemies contain the key G? Yes, it does, right here. But it says its enemy is D. So we're gonna go, all right, is D in here? It is not, so counter remains at 2. Now, you may have already noticed something. That's great and all, this logic works perfectly. But the problem is, how do we know if it contains? How do we know if it doesn't contain? Because these are just presently 3 separate values, right? A, C, G, separate. Here's what we do. We put these in an array list. That was a weird way of drawing 3 boxes, huh? We put these in an array list, and we can call this array list current. Now you might be asking yourself, why an array list? What's the point of an array list? Well, this array list gives us a lot of functionalities. The first thing is we can get indexes. So we go index get 0 and it'll return A. Get 1 and we get C, and get 2 we get G, right? So we can get stuff. We can also use the function dot contains. Dot contains tells us if we have that a random value in the array list. We can use dot add, dot remove. The functions are endless and they can really help us out right now. So we're gonna put this in an array list. I'm gonna call the array list counter, or we're gonna call the array list current. And now we're gonna go, all right, like we just go through the logic again. Is A. Does friends contain the key A? Yes, it does. B. So we're gonna go loop through the array list, the values of the key A, and that's just B. So we go, all right, does current contain B? Simple as that. And then we do the exact same thing for enemies. And we're so close to finished. Because technically that's all correct and everything works well, except for one small problem. Here's the thing. Let's say the G lines go something along lines of ACG for the first line, B, D, L. I don't even care what these are, right? For our sake, for this moment, we don't really care. Because all we care about is the fact that A broke a constraint, right? When we went through A, we realized that A broke the constraint, broke, to be more precise, this constraint, where A has to be with B, right? A is not with B, hence A broke the constraint. Now we go to this line and we go, all right, B is also not with A. So we broke the same constraint. We broke the constraint again. That means for every constraint for every single constraint that there was, we broke it 2 times. And that's 2 times more than the output we should be giving. So instead of figuring out that A is not with B, hence we should increment the counter, and then go B is not with A, hence we should increment counter, the first time we realize that A is not with B, we're going to go increment the counter, but also remove B, we're going to remove A from the value of B, from the value that B is pointing to. Now you might be a little bit confused. So let me build on that. If we go key, so let's go key in the friends hash map. The key points to a value, right? So key is A in this case, and it points to B. This points to the original key again. How? Well, right here, we see that A points to B. So B points to A. So all we gotta do is just eliminate key. We gotta make that disappear. That way, we have solved the repeating issue. So when we're trying to figure out if a value is with its friends or when it's not, or if it's not with its friends, then we're also gonna go, all right, we're gonna eliminate A. So if we see that A is not with B, then we're gonna go, all right, B, ooh, sorry about that. Let's go back, fix that. B, now eliminate the value A from the values of B. So we're gonna eliminate this. Now I understand that's gonna be super confusing, right? So we're gonna definitely go code it out, and I'm sure it's gonna make a lot more sense when we code it. But simply put, we're gonna remove the key, the key's value that's pointing to the key. I know, this is super confusing. Also, I've thought about the idea of maybe just dividing the results by 2. I have thought about it, and we're going to test it out too. We're going to think about how that would work out. I haven't tested it, to be honest. I didn't think of it when I was originally solving the question because I took the CCC like 2 days ago. So we'll see. It's going to be interesting. But yeah, that should be about it for the iPad. So now let's go ahead and code it. Okay. All right. Okay. So the first thing we gotta do is we gotta import Java util, right? We gotta import it. This gives us ability to use all the Java utils like scanner, like the classes, scanner, hash maps, array lists, arrays, all those. It automatically imports it for us, so it makes our job a lot easier. But we still have some jobs left, like initializing scanner. So we're gonna go scanner.new scanner system.in. Also, we need to make 2 hash maps, right? We already knew this. 2 hash maps where we have a string, the key string, that points to an array list of strings. We can call this friends. And this is equal to a new hash map of strings, array, list, string, boom. All right, we're gonna copy paste this and then go enemies because the exact same format, right? Just this time, we already know in our head that, oh, this is not pointing, like this is saying that they're not connected, they can't be together. All right, now we get the inputs. The first input is X, right? The first input is X, and this gives us the lines, the pairs that are meant to be together. So we're gonna go int X equals int.nextInt. We're then gonna go loop through that. We're gonna go ahead and loop through that. So we can go int A equals 0, A will go up till X, A++. All right, Now we're going to go, what do we get? We get two values. We're going to go string temp1, whatever, in.next. Notice how I put in.next. In.next gives me the next block of string and stopping at the next space. Next line gives me the entire line, including the spaces. We don't want that, right? So we're going to do that. Copy paste this. It's temp2, right? We're just going to change the name. All right. Here comes I don't know if you remember, but earlier we talked about how we're going to add these all in the hash map. So here, this was the logic. It was, all right, if, keep in mind, X is friends, right? So friends. The logic was, if friends contains the key of, for this one, we're going to do temp1, but keep in mind, right after we're going to do the exact same thing for temp2. We're going to go, if it contains the key of temp1, then we're going to go, all right, it contains it. So all we got to do is we can go friends.get temp1.add temp2. So what's going on right here? This is a little bit confusing code, I bet. But basically what it's saying is friends.get returns an array list. So get returns an array list. All we're doing is we're adding to the array list. So we're just adding to the value. We can easily just .add, .remove to the array list, right? Because it's getting that. All right, beautiful. Else. Now, if it doesn't have the key, however, if it doesn't have the key, then that means we have to put it in. The thing is, we can't just put temp1 as a key and temp2 as a string as a value, right? Because that's not how it works. We went temp1 is a key, and it's just a string, so it works. But temp2 has to be in an array list, right? So let's initialize an array list. We're going to call it array list of string, and we're going to call it temp array list every time. And we're going to go new, copy paste this for time's sake, like that. All right, and now we're going to add temp2 to it. So temp array list dot add temp2. Bingo. All right. Now we can put it in the front. So we go friends dot add dot put. I believe it's dot put. There you go. Temp2, temp1, and temp array list. Beautiful. Now you might be wondering, okay, how do we do this for temp2 then? Right? Because if A points to B, then B points to A. All we gotta do is just reverse it. So we go copy paste. Give it a couple spaces, and we just reverse it. So temp1 is now temp2. Temp1, temp2, temp1. Right. Let's hope that we didn't make any mistakes there. Just checking. All right. Cool. So we got all the X's. Now we go on to Y. All the pairs that aren't friends, mortal enemies, or enemies for life. Okay, exact same thing. We go int y this time, however, and this is enemies, right? Go int y. This is going up till int y. All the enemies, all the friends are now y's. I mean, all the friends are now enemies. So we go enemies. Okay, let's check the code one more time. Make sure that we did not forget anything. Beautiful. All right. Now, we've gone through all this code, or if we go under a little bit, we have gone through all this code, and now all that's left is to solve the constraints. So, let's do two things. Let's go int g equals int.next, right? In.next int, let's just clarify. And then we're gonna go we're gonna initialize a counter. This is gonna count all the constraints that are broken. I can spell constraints, right? Constraints broken. Beautiful. All right, now we're gonna loop through the number of constraints, or number of teams, so G. Now we're gonna go, all right, what do we get every single time we get G line. We get 3 inputs. And remember, we want to put these 3 inputs in an array list. So we're going to go, all right, let's initialize a new array list that has strings. We're going to call it current. It goes new array list, string, and we're going to add the 3 values into it. So we're just going to go int.next 3 times. So we're going to go int a equal, no, b, right? We already have a. B goes up till 3, b plus, and right here we're gonna go, actually just to make it clean, we're gonna go just like that. Current.add int.next. Beautiful. So now we're gonna get all the inputs we need. We have the entire line. Okay, now what? So we have current and has A, C, and G. Now we go, all right. We figure out if it has friends and if it's breaking any constraints when it comes to friends, and we're going to check for enemies. Same thing for enemies. So we're going to go, all right, if current.get1, so current at the first index of current, the first element in current, so in this case it would be A. We're going to go, all right, does friends even contain that? Does friends contain the key A? So we're going to go if friends that contains the key current dot get oh shoot, no, sorry, I just realized I made a very big mistake. We have to loop through these. So we're going to go int a equals 0, b will go up till 3, or let's just make it dynamic, current dot side. If you're wondering what I'm doing, I'm just looping through the array list because we're meant to loop through them. There you go. Yeah, because that way we can go through these. Presently, I was just looking at A and just A. No, we need to loop through the current values, and then we'll go and look at A, C, and G. There you go. Okay, that's better. I was a little confused because that was wrong. Weird. All right. I see a lot of parentheses here. Okay, if friends.contains a key current.get B. There you go. If current.contains a key, if friends, sorry guys, it's a little bit confusing after a while. All right, friends that contains a key current.get B. Then it's B++. There you go. See, that could have been a very big problem later on. Why is there an extra area there? What? Why? Wait. Oh, yeah. Okay, that makes sense. Sorry about that. I missed the parentheses and I was confused about what's going on. Sorry about that. Okay, right back on track. So, if friends contains the key A, in this case, if it contains A, or current.get B, right, because we're looping through the current array list. If it contains it, then we're going to get the array list. We're going to get the values. We're going to get the list of values. We're going to go, all right, array list, current array list, or current array. How about this? Current array. This is going to hold strings, and it's going to be equal to friends dot get. So this is going to return the value, and we're going to put the key, and it's going to return us a value, and that value is current dot get b. There you go. All right. Now we have the list of values, and keep in mind it's just A, right? Because A only points to B, so we have V. Still, we need to loop through that. So we need to go loop int C equals 0. C will go up to current array dot size C++. There you go. So we loop through these, all the values that A has, the key A points to, and now we go, all right, if current does not, right, because we're for the friends section, if current does not contain these keys, does not contain these values, then increment, good old counter right over there. So we're going to go, if current does not, right, current does not contain the key, and that key, or that value actually, will be current, I can't see the array anymore, current array dot get C. If current does not contain it, right? Because keep in mind, presently we're just looking at B, right? Its sole value in the array list is B. So we're saying if this line current does not contain B, then increment counter. But also remove it. Remember the remove the keys values value? Well, we can go ahead and do that. And we can, by the way, by the end, I'm going to also try the divide by 2 idea. So we're going to go, all right, remove the keys value. So friends, because it's all in the friends hash map, friends.get current array dot get C. This is where the B is. And we're going to go dot remove. And the beauty behind the remove is we can get the int, so we can get the index, or we can just get the object. So we want to remove the object, which is in fact current.get B. So A in this case. There you go. A lot of function parameters inside of function parameters inside of function parameters. But simply, we're looking at B, so friends.get the values of B and remove A from them. Simple as that. And that's all that there is to this. If you wonder how the enemies goes, we just reverse it. So we go enemies. Copy paste that. Ooh, not entire line. Copy paste enemies. Oh my god, I did it again. Copy paste. Copy print or copy V or paste. There we go. I know how to say paste. Paste current if it contains it, right? This time we want to go if enemies contains it. We don't want the enemies to be in the line. So contains, print, and that should be all. All right, I think that's it. We're going to talk about logic one last time, but I believe hands crossed, or fingers crossed, we have a working algorithm. I got 2, 3, 3. How did I get 2, 3, 3? Oh, I'm looping through it, aren't I? Yep. Sorry about that, but something tells me I already got this right. Boom, boom, and that's not it. Okay, and 3. And we can try the top one too. Sure. All right. Wow, we made it through the video. I've gone to this. I practiced this video maybe like 10 times. Wow, it's tiring. I would love to go on Daemage or whatever, or maybe like CCC Grader and test this out against all the cases, but the contest is still not over. I did the contest 2 days ago. If you're wondering, yes, I did this during the contest and I got 15 out of 15. I got full points and its time complexity was super low too. So yeah, this does in fact work. Hopefully by the time you're watching this video, Daemage or CCC will have let you or have like added the test cases, so you can go ahead and test this. If you don't believe me, go ahead and just test it. You can go get the code from my GitHub. Before you do so, however, let's try the divide by 2, because that's gonna be interesting. What would happen if we don't have this? Ooh. This can potentially be significantly more efficient. Now for this one, it should just be 0. Right, but for this one, 3. All right. So, unfortunately, I don't know if that's going to work against every single test case. Going through the logic in my head, it should work. But I'm not sure. So, I have the code in my description. Go find it. Go copy paste it into the module or something, and see if it works. I'm not sure. All right. I feel like that's it. We went through all the questions. If you guys have any more questions, please feel free to let me know in the comment section. Also, optimizations. I love to know them. As of right now, I haven't talked to anyone about CCC, so I can't wait until the results come. All right. Thank you guys so much for listening, so much for watching. I hope you learned something. If you learned something, please share with someone else that you think would also like this, computer science nerds and whatever, including me. All right. Thank you guys so much for listening. See you. Bye.